Hello, and welcome to the channel, welcome to the video, and welcome to the series. We have another small update today. I have been working on electrics and some husbandry items, mainly in the engine bay, which I'll show you in a second. The main thing that I've managed to do is to sort out the starting system for the motorcycle. Now obviously I can't start the engine because the stator cover and the stator itself for the charging system, the cover itself holds in the idler sprocket for the starter motor. So although I can bump the starter motor to show that it's actually spinning, I can't start the engine. Two main reasons. One is that I don't have fuel for the engine, and the second is that the stator cover actually holds oil as well, so there is no engine oil in the motor at the moment. So although I can bump the starter motor just to check that the starting system is working correctly, I won't be able to run it for a while yet, actually, until I get a fueling system. So what have I done to allow that to work? Well, on the motorcycle harness, I'll show you one here on my computer actually when I get the image up on the screen. So if we have a look on the screen here, we have this is for the ZX9R, and thank you to the gentleman that sent me this. I think I put his details in the comment section down below, or the information section down below. I can't remember if I did. If I didn't, I'll put those up in a second. So what we have up here is the starter switch, the stop switch or the kill switch, the igniters for the engine. Sorry, the coil packs for the spark plugs, and then the main ignition switch up here, and then down at the bottom, if I scroll the picture up, we have the battery, the starter relay, the starter motor, and then across this side here we have the neutral switch, the side stand switch, and the clutch switch. Now, it does show on here fuel cut-off valves, which are, if the bike tips over, it turns the engine off. They are only for Germany and Switzerland. They're not fitted to this engine or loom. So, what I've done, it doesn't have a side stand. It doesn't have a clutch lever. It also doesn't have, if we go back up to the top, a stop switch. The stop switch is an American market thing, which has kind of bled throughout the world. It's a big red button on the right-hand controls, right-hand handlebar controls, which is a kill switch. So for whatever reason, you need to stop the engine and the key's not working, or it's running past, or whatever it might do, or running over, sorry, you hit the kill switch and it will disconnect power from from most of the system actually, and turn the bike off. That's not necessary. It's not the best or worst or any kind of way of switching the engine off. The best way of switching the engine off is with the key or the ignition. With the setup that I have in the bike, I do still have the key for the motorcycle loom, which is here. But as said in previous videos, that may be disappearing, or it may be on permanently and then hidden. But the main power on and off, the main ignition on and off, is going to be here, which is the main battery master cutoff. So once that's off, everything goes off. Fuel pump, ignition system, alternator, stops getting an exciter signal, everything turns off. Which is the way it should be, really. In fact, no, the only system that doesn't turn off is the brake lights, because I've wired that pre-battery master cutoff. So it's the only system that is wired directly to the battery, is the brake light switch. Okay, so if we come up here as our neighbour is doing his lawn mowing, I do apologise about the sound, but nothing I can do about that. So the fuel pump relay has been disconnected. That piggybacks on the other signals here, so there's no continuous signal through the fuel pump relay, and the fuel pump that I have or will be fitting in here is standalone anyway, so we can ignore this entire section here. That does nothing. Brake light switch, again, I've got a brake light switch for the car, so ignore that one. If we go back over to where the start and stop switch are, the stop switch is a normally closed push button switch. So when you let go of it, it's closed, it completes the circuit. And what that does, it puts this earth line, okay, in line with this power here. So that power, the positive here, it's making a connection to the coil packs, and then it drops that down through the junction box down through to the igniter box, which is down here. That circuit there, if it's disconnected, it will disconnect the power supply to the igniters. However, because I don't have one, the plug, which is this here, was open. There was nothing on the end of it. So what I've done is I've looped a wire around here in the end of the plug and crimped it shut. So this is now bypassed. There is no stop switch. It is completely closed loop, or a closed loop of wire. Not to be confused with closed loop in ECU mapping. The starter switch is a momentary switch. What that means is that you press it and it closes, and then you let go and it opens again. So with this here, I don't have the buttons for the controls. I don't have the motorcycle controls at all. So in order to get that to work, again, gone under the dashboard. Luckily all this is on the same plug. So I've gone under the dashboard and found the red wire, which is permanent battery live, and the black and orange, or blackened. It's actually like a blackened off yellow colour. It's not really orange, but it's blackened off yellow. These two here, again, what I've done is taken the wires out of the connector and then wired in on the right hand side of the dashboard there, that silver momentary switch, which is now the starter button for the engine. Moving on, the cut-offs for the what have we got? The cut-offs for the neutral switch, the side stand switch, and the clutch switch. So the side stand switch was in the engine bay. It was one of the first things I did. Was again the same as the cutout switch at the top there. I've looped a piece of wire around and then crimped it in so that it bypasses the side stand switch. The clutch switch. Now the clutch switch is on Suzuki's and some later Kawasaki's. What it does is when you pull the clutch in, it sends this wire here, the yellow and green wire, it sends that to earth. So it references it to earth, which is here, which weirdly goes through the horn, but it goes up here, down, it goes across there and back up to the junction box, and it eventually goes to an earth. So that references this yellow and green line, which goes up here and up to the junction box and then comes back down and through the starter solenoid. Okay, so if it's not referenced to earth, as in you've pulled the clutch in, the starter solenoid won't work. However, if you've got a neutral switch, the neutral switch provides an earth for the starter relay. So if you've got it in gear and your neutral switch is off, there's no earth for the starter solenoid, so the bike won't start while it's in gear, unless you provide that line with an earth by pulling the clutch in. So you pull the clutch in and it'll start if it's in gear, or if you let it out, so it cuts off the earth for this line, then it has to be in neutral for it to start. What I've done is the neutral switch is wired in temporarily. If I show you this here, So this plug here is for the stator, which I haven't got yet, and on that light green wire there is for the neutral switch, which is underneath here, which will be able to be plugged in once I get the stator, and they've got the other side of the plugs there. So I've just referenced that to earth by connecting it to the earth point here, so that I can test the system. And then what I've done is, when the clutch is out, so you let go of the clutch, these two connectors here, the light green line, which is the same one as the neutral switch, okay, references this line here. So there's two separate references for the clutch switch. One's in, one's out. One is negative and one is positive. One is negative, one is positive for reference to the starter relay. The light green line goes back up to the junction box, and is some magic happens and that works. So the neutral switch will be wired in correctly, because I would like to. It lights up a neutral light on the dashboard and gives you an idea that you can let go of the clutch when you're parking and you don't stall the engine. So that's a good thing to have, which I now know where it is and will wire in. The side stand switch, again, like I say, has been bypassed. The clutch, I've connected these two together. That's the yellow and green and the light green. So it's permanently in the out position. What that means is that I will only be able to start the engine if it's in neutral. I don't have a problem with that at all. And again, it would be something you do in a car anyway. If you stall at a set of traffic lights, it's handbrake on, car in neutral, start the car, back in gear, off you go. That's a normal thing you would do. The difficulty on a sequential box is finding that neutral and making sure the light comes on the dashboard, which again is why it comes in handy. With that then, we have the starter motor wired in, we have the starter relay wired in, we have the battery wired in, we've got the neutral switch wired in, the side stand switch bypassed, the clutch switch bypassed, the kill switch bypassed, and more importantly, the starter button. So if we go around the other side, oh god, there's so much crap on the floor. Open the doer. If we turn the battery master cutoff on, and wait, doobie-doo, there we go. So you've got the oil pressure light, because there's no oil, and the neutral light. That's a neutral switch there. Listen carefully. If we press this button, we have life. Now, like I say, it's not going to spin the engine over because, turn that back off again. Like I said, this here, whoa, where are you? There you are, there's my hand. This is the starter motor, this is the idler sprocket, and this gear here comes out. Now that back gear connects to the flywheel to start the bike. So that's a, is that bolted in? No, I don't think it is actually bolted in. So that's a starter there. I'm not sure if that's on like a centrifugal clutch. It must be on a centrifugal clutch, otherwise the starter motor would be permanently attached to the crank. So I believe that's on a centrifugal clutch for starting it, and then you've got the idler sprocket here. But like I say, the cover that goes over the stator holds this pin in and holds the idler sprocket in place. So all I can do at the moment is bump it. The other thing I've done, the speedo sensor, which is, oh, sorry, you're looking at a wiring loom. The speedo sensor here, which I've just placed inside this cover. So that's here, which covers the sprocket, the front sprocket. I've modified that cover. So if we go underneath, where's my hand? There we are. So I've modified this cover here by cutting away all of this section at the bottom underneath the sprocket, because the chain will actually come down out through here. So this cover actually came all the way to the end, and the chain come out the back for the motorcycle. It was now going to come straight out the bottom. So I've cut all this away at the bottom. There's another 4 bolts and studs to stop this from moving around. It is literally just a cover, but it's mainly there to hold the speedo drive in place. The speedo drive, I also think, is a pickup for something or other in the engine, and I can't remember what it is. It's not gear position or anything like that. It's something else that I can't remember what it was that it picked up on, but that is a requirement. So I can't get around the fact that I need the there it is, speedo drive. What else have I done? Well, as I said last time, I would P-clip the loom to this bar here. So I've put a stainless bolt through there and made a P-clip out of some thin aluminium there, just to hold the loom in place. I'm going to put another one up here and get rid of this cable tie as well. Probably put it on the earth strap here so that it's a nice straight run through to the main loom run along the back of the engine there. Sorry, the wrong way around there. The top of the engine here, there's normally a breather system on here, 2 holes on here and 2 lots of reed valves that release gas pressure when the engine's at high RPM, lots of vapours, and those vapours then go through a solenoid valve into the inlet when you lift off the throttle. Anyway, you lift off the throttle and it burns the excess gases off inside the engine. I don't want that. I don't need it. It's a system that the modification that's being done is called the clean air system, which basically gets rid of all the rebreather systems, all the crankcase breather system and everything that's supposed to go into the carburetors to burn it off is now not going to be there. It's going to have a catch can fitted to the crankcase breather, so that's I think that's a gearbox breather there actually. So I'm going to have a catch. I've got a catch can somewhere. Where's the catch can gone? There it is. So I've got a catch can, probably get a different one with different connectors on the end. But there will be a catch can on there to catch the excess fluids that will come from the vapours that are released. I mean, here's another one here that's supposed to come, the vapour's supposed to come out of here and into there, which then goes through this hole and gets sent into the inlet manifold, or the inlet trumpet, sorry. So that'll be getting blocked off. That pipe will get removed. In fact, I'll probably do that in a minute, take that off and get rid of it. It's in the way. So these I've made by hand. I've cut them out of 3mm soft malleable aluminium, so I was able to get them flat. Inside here there is an O-ring that goes all the way around. So these are nice and flat on there, they're nice and tight, and the O-ring has sealed them up. So that's got rid of those. You leave the reed valves in there because the reed valves hold the O-ring. If you can see on the back of this one here, where the O-ring sits along the edge, it is just a flat bit of aluminium. So it's just changed from that to that, and got rid. The other thing I've done, or another thing I've done, I've ran some conduit for this main loom here that runs through to the clocks, or the clock loom should I say, and the starter cables. So I've run some plastic looming, some conduit through the firewall there to protect the wiring. I am going to run a grommet on that. In fact, I'll probably pinch one of these grommets and then seal those holes up, or find another grommet and put a grommet on this hole here just to stop it from rubbing through the conduit. Again, I'm going to run a lot of these cables here will be rerun, reorganised. I'll probably cut the looming back, cut the tape back, and then rerun them so they're a bit tidier. And the last thing I've done is I've mounted the voltage regulator, so that's now mounted to the chassis. I've got this sheet of aluminium here, and made a cover for the electronics. It's not sealed at the bottom, it's still open so I can still get in there. But you've got, on this, you've got 2 bolts here onto a bracket which is flat against there, so it's an L-shaped bracket that way. This one here is a stainless steel bracket that I've made from an old number plate bracket. Let's see if I can find the other half of it. Where did I put it? No, that's gone missing. It was, like I say, it was a number plate bracket. It was one of these tilting number plate brackets. So I used half of that, and it was flattened this section out here so I could bolt it through the headlight mount, and then there's one bolt there and one bolt there. So that is because the aluminium is bent this way and then back that way with an L bracket, stainless steel bracket in there as well, and it's got this bracket on, and there's this little stay up here which just stops it from rattling around. That's quite strong in there now. Yeah, it's flexible in the middle and it needs a support at this end, but I'm not finished with it yet, so I'm probably going to make a little bracket up here. I'll go through the hole in the chassis there and come back this way and hold it in place. And I think that's pretty much it. Update on the last video. I think it was an update on the last video. I've managed to source a differential, and it's not a Honda S2000 differential. It is a Mazda RX-8 differential from the 240 horsepower ProDrive RX-8. So it's what they call a Takagi Fuji limited slip differential. All of the differentials I showed you so far and how they work, this is not that. This uses a set of spring plates in the center of the differential in order to sense speed. It's a mechanical speed sensing differential rather than torque sensing. So if a wheel starts spinning, the faster it spins in relation to the other one, the more torque is applied to the opposite wheel. So if torque is a measure of acceleration over time, then the acceleration of that wheel over a set amount of time, it is technically torque sensing, but it doesn't sense a difference in torque between the two. It literally detects a difference in speed. So if you clamped one wheel and lifted the other one in the air and put your foot down, the faster that wheel went, the harder the diff would try and turn the wheel that you've got clamped. So anywho, it's a limited slip diff. It was 20 quid for a limited slip differential. If we hark back to the first 3 videos, I was talking about the reasons going for motorcycle engine and front wheel drive LSD and the cost of doing so. This is it, 20 quid for an LSD. It comes with the output drives or the output CVs, so it is literally, it doesn't have flanges on, it is literally just the slip-in CV joints, much like the Micra one I showed you the other day. They slip straight into the differential. The bearings will be knocked off the output drives, and it will be having bearing blocks pushed onto there or pressed onto there, and then they will be bolted to a frame which I am yet to build. Then it's about getting the chain sprocket mounted to the diff. That's going to be the hardest bit. I will have to get somebody to machine me a spacer with holes in to get the diff, to get the sprocket mounted on the diff. That's going to be the hardest part, because I'm going to have to part with some money, which I don't want to do. So that's where I am at the moment. The bike starts, or the engine, sorry, turns over. I've got past all of the little niggly cut-offs and safety features that would be included in a motorcycle, which are no longer needed in the car, and I've managed to tidy up the engine bay a little bit. So thank you very much for joining me. Again, if you want to like and subscribe, share the video, watch it as many times as you like, or as many times as you want. And Patreon, Facebook and YouTube all support the video. The more it gets out there, the more I can get on with doing more videos, and the quicker the progress of building the vehicle will come. Thank you very much, and I shall see you next time.